get to the last part of your prep. So going from study unit 6 to the last study unit. Okay, so this one, as you can see, I've now started nearly with a definition question. So in the definition, we're now being asked, but which one is incorrect? Again, nearly making sure that you need to just check which one is the incorrect one. So if you look at it nearly, unfortunately, you need to go through all of them. And hopefully there's one that stands out as being definitely incorrect. So standard normal distribution is symmetrical around the mean. That is correct. The standard normal distribution has a mean of 0, standard deviation of 1, also correct. So that is nearly, you can look at how the Z is distributed. So mean of 0, standard deviation of 1. So that is also correct. Standard normal distribution is discrete. Definitely not. So it's a continuous distribution, not a discrete. Remember, discrete is again something that we've done in chapter 5, where they will give you, for the value of x, you've got a probability. So just again the difference. So let's quickly check. There was, so for, and this is discrete. So for the probability of 0, you get a probability 1. Remember when we worked with chapter 1 and 2, we've defined what discrete is. So discrete is 0, 1, 2, 3, 4, 5. Where if you look at your standard normal distribution, that is continuous because it can be nearly anything on a straight line. So that is why standard normal distribution is continuous. So that one is the incorrect one. But let's just, the other ones, the area underneath the standard normal curve is 1, which is correct. So remember, probability underneath the curve is equal to 1. And then the other one, the normal distributed random variable x, can be standardized according to the formula z is equal to x minus mean over standard deviation, which is also correct. Okay, so the one that was definitely incorrect is that standard normal distribution is continuous and not discrete. And again, this one was a bit easier. So again, there will be a spread of easier and more difficult questions. And hopefully the easier ones is the ones that you definitely get right and not being catched out by anything. Okay, so then we go into we go, let me just okay. We go into working out the normal distribution. So this question very specifically asks us to work out the probability that x is between 105 and 115. So so when we're gonna look at this, we're gonna, and let's just make it we go again, and this is something that I think is probably going to be in your paper. So because it's asking you to get the probability between 115, 105. I now made the assumption that it needs to look like that, but again, not, because if we draw in the mean that is in the middle, we see that the mean is 100, and 105 is going to be somewhere there. Okay, so we're going to need to work out the area that is now highlighted in red. So just by looking at that, the probability can't be 1. Okay, there's just no ways, because then it should have been everything. Looking at that, the probability cannot be bigger than 0.5, because in this area I'm already sitting with 0.5, so there's still going to be another area added. So, and here's going to be a piece also still. So I'm only looking at that piece for my probability. So it can't be bigger than 0.5, can't be bigger than 0.5. So if I now needed to guess 1 or 2, so now suddenly you don't need to worry about 5 options. We have eliminated 3 of them already. Okay, so but now unfortunately, to get it right, we will need to do the calculation. So how I would nearly write it, just to make a bit more sense, is to say, okay, well, the one is 105 minus 100 variance. So now again, a catch, because we need to get the standard deviation, so that we don't work with the variance, but the standard deviation, that is 5. Then the other side is 115 minus 100 divided by 5. Okay, so we're then going to work between probability of 5 over 5 and 15 over 5, which is between 1 and 3. Okay, so then if I transform this into my Z, and now again it will probably disappear first now. Okay, so that is 0, that is Z1, that is Z3. So again, we're looking for that area of a probability. Ooh, okay, so here probably what I would do is get the probability of Z equal to 3, then subtract the probability of Z equal to 1. So let me get to my table. See when we can get to a table. Still part of. So again, if you guys don't have a printed version for the exam, what I would do, so that you don't need to nearly look for it every time and open and things like that. What I would do if I were you guys, and let me quickly, so on the PDF, I will nearly make a comment. So you can see I've made lots of comments and highlights. But if you only have so don't make 58 comments because then again, going to be very difficult. But if you now make, and you can add text, and when you say, well, this is the Z table. So that when you nearly in the exam, you look, okay, let's go. There's my Z table. And so let's say I was somewhere else. And then I just say, I basically just go to there, and there it is. Okay, so there is also, just make comments in this. You will now see every time I highlighted it, it made a comment. So that's also not not the best way, because now you suddenly have a lot of them. But make a few tags to say Z table, T table, and the things that you really need to get to. Okay, so we've got Z equal to 3. So that was 0.9987. And then we're going to say subtract Z equal to 1. Z equal to 1 is 0.8413. So when I do this, then I'm going to say 0.9987 minus 0.8413. And then my answer is going to be 0.1574. Okay, which is option 2. Those two are very close to one another, so it's not really very easy just to say that you can just one will be correct and one not, and easy to say which one. So unfortunately, with this, you need to do the calculation still, unless you just go for a guess between the two. Which one to guess for would not have had a faintest idea. So again, see how far you can to do a calculation. Okay, the chances is very good that they ask you one that is between 2 points. Okay, so just be on the lookout. It can be that it is, instead of 105, it's maybe 95. So then it does take a different shape. But then just make sure nearly beforehand, draw a diagram, and see what nearly can happen, so that you can at least try to eliminate a few options. Okay, so from this one, now we're going into a much more difficult one. So now they say, consider the standard normal curve. If Z is between those two values, which we don't know yet, and that area is equal to 0.5, then what is the value of Z? Okay, so how would you have done this? What what would you have nearly tried to do with something like this? Okay, cool. So how would you? Okay, you're going in the right direction. So not 0.5, but as I remember, so if this is 0.5, here's going to be a 0.25. Here's also going to be a 0.25, but we're not going to work with this one. So we can look at this area where it is 0.75. So then we nearly reverse the result. So that's spot on. We reverse it. So we go to the Z table. By reversing, we are looking for 0.75 in these numbers. Okay, so 0.75 in these numbers. So 0.7517, 0.7486. So it's nearly in between these numbers. So what I could tell you in the exam, it's going to be 0.67. They can give you 0.68 because you kind of said it's close to that as well. Or they could have been 0.675. There will not be all three options for you because that is not feasible, because you can actually decide on what the outcome. So so you will see the options is the 0.675, which we have selected, but you will see there's not a 0.67 and there's not a 0.68. Because to be honest, if there was those two as well, I would have said, but it can be any one of those three. But again, what I would have gotten out of this is, okay, Z, yeah, already I know Z is 0. So Z can't be 0 at that point as well. So that just can't be. So one thing already we could have taken off is Z equal to 0. What we've done here is basically to say, well, if that is 0.5, maybe you wanted to say, but that is also 0.5. That's where the 0.5 comes from. The other two, I don't really know, because again, 0, so let's quickly, okay, so if you only use 2.5, 5987, 5. So if you only used 0.25, you would have gotten that as an option, which is also incorrect. Then maybe if we looked for 0.5, let's quickly check if we looked for 0.5. No. So again, sorry, 0.5, 0.6915, 0.6915. So that is if you were looking for 0.25 as the Z, and this was if you were looking for 0.5 as the Z. Okay, let's quickly, so how do I get to the 0.75? So they tell us that I'm working with, between these two values, my probability is 0.5. Okay, so between these two is 0.5. Remember that with your normal distribution, it's always in symmetry. So if this area is 0.5, between 0 and Z will be 0.25, and between 0 and minus Z will also be 0.25. Okay, then what is left? this area and this area, and the two of those areas must also be equal to 0.5. So again, symmetry, because both are equal to 0.5, I can say 0.5 divided by 2 will give me this area, which is 0.25, and this area, which is 0.25. So then to get up until that Z value, I use the probability of 0.75. Okay, so let's do another example, because 0.5 is always the easy one in a sense, but it could have been, and let's just change it a bit so that you guys can see it as well. So they could have said this area, instead of 0.5, is 0.6. So then again, we know that this area is 0.3, this area is 0.3. What is left is those two areas, that's together 0.4. And now it's again, well, it's symmetry. So this one is now 0.2 and that one is 0.2. So now you would have gotten a probability that you needed to look for that is 0.8. Okay, so then again, what we would have done is gone to the table. And in here, we will now look for what number is closest to 80. So if I look at closest to 80, it would be one of those two numbers. So again, we would have probably said 0.84 or 0.85 or 0.845, again, depending on what options they give you. But the most important part in this is that we're looking at symmetry. So it doesn't matter nearly what number they give us. Remember that you can halve it to say on the one side it's half of it, on the other side it's also half. And then because it's symmetry, this side, so nearly this side needs to be equal to 0.5. And this side needs to be equal to 0.5. So whatever I have in here, so if I've got 0.25 like we had, this part will also be 0.25. If I have 0.3 here, this will be 0.2. If I have 0.4 in here, this part will be 0.1. Okay, but every time it's basically to do with a symmetry that everything is cut in half. Does that make more sense? Okay, cool. And again, I think just they will not give you a number like 0.55, or they would give you things that you can actually make you can break up very easily. They could have, yes, they could have asked for minus Z as well. So if they've asked for minus Z, you would need to look for the 0.2. Or now in this example, the 0.25. And but now, okay, so that was 0.2. So obviously here you would see there's no 0.2. So you need to then go to your negative table, 0.2, or let's say in that other instance, it was 0.25. So somewhere in here, and then it was just negative 0.645. So just the negative 0.67. So sorry, if you looked at the 2, 5, it will just be negative. So also very important is what I would also look out for is, and it didn't happen now with this one, but what they could ask, so remember that Z, whatever that positive value is for Z, in this instance, it was 0.675. The negative value will be minus 0.675. So what they could have done, and that is most likely what they will do with the 2 or 3 different options that you guys are getting, that one of the questions to some of you will be the positive Z. Some of the questions, or the question to some of you then will be the negative Z. And in your answer set, they might give you the positive and the negative. They might just give you all positive. They might just give you all negatives. But that is probably what will happen in a question like this, where some of you guys will need to work out the positive Z, and some of you will need to work out the negative Z. Okay, so thanks for that, Patrick. I think that's also important, nearly when you and nearly do the mock exam a few times, because I think there is, if I'm correct, there's also more than one mock exam. I might be wrong, but I think so that you can just also see, like you guys did in all the assignments, is that and all your assignments nearly already prepared you. There was always the second attempt, something was different, but not nearly the whole question, just some of the values, or maybe the standard deviation was known, where in the previous question it was unknown, or something like that. So that is the small differences in the different papers, or in the different questions that you guys will have. Okay, so let's go to the next one, and now you can see these was basically from study unit 6. We only looked at Z. There wasn't a mention of sampling. Then we go into study unit 7, and the questions around study unit 7 start. So a month after cyclone Idai, Durban in South Africa experienced severe flooding with mean rainfall of 165 mil. Standard deviation of that. If a sample of 10 rain gauges are selected and rainfall measures are normally distributed, calculate the probability that the mean rainfall measurement will be at least 100 mil. Okay, so what would you do here? Z or T?
I would say T just because of the sample size.
Okay, so sample size is small, so less than. Do we know if it's what the population standard deviation is? We don't know what the population standard deviation is. Okay, so that already tells me that I would probably work with a T. Does the rest of you agree? So what would you say if this was now your exam question? what would you have said in this one? Distributed calculate for probability. Hmm. Okay, and does it matter if we look at this, if it is a T or not, because are we working with confidence intervals? So I'm now nearly playing devil's advocate here as well. So does it matter if the n is smaller? So what are we wanting to work out? So I'm just, yeah, I'm not trying to confuse. I'm just asking a few different sets of questions. So if this was your exam question, what would you have done? And the reason why I wanted to talk about the T and the Z, when did we start looking at your T distribution? And what is the reason for the T? So in this instance, okay, T is for confidence intervals. So and I was blatantly nearly trying to confuse you with this one, because again, in the exam, we're so fixated at looking at, okay, standard deviation, sample, not sample, population, is it, I don't see population, okay, sample, it must be T, but yeah, so T is for sample or unknown standard deviations, but only when it comes to confidence intervals. Okay, so when we do, and not just confidence intervals and some of our hypothesis testing if needed, but when we just need to work out the probability with given facts, we still use the Z. Okay, so we only start using T when we're looking at a confidence interval. So with this one, still straightforward. Need to work out the Z, need to go to the diagram, gonna work out Z, gonna look at it and say, well, if something is bigger or equal to 100, at the moment, I don't know where that Z value is gonna lie on here. At the moment, it seems like, or it can be way on this side, but then, or it can be totally on the other side because it's nearly like two big numbers and two smaller numbers. That adds to 1. That adds to 1. So just nearly doesn't matter which one it is. We must be very careful when we write it out that we do the right thing, because if we just swap the numbers around, we will pick the other one. So and you guys can now clearly see very close. So it nearly feels it's going to be one of those two, for one of those to probably, and I'm just scratching out none of the above. Okay, so let's quickly look at what is the X. So at least 100. Your mean was 165. Okay, so that already tells me I'm gonna lie on the negative side, because that is going to be negative. So somewhere here gonna be negative, and I need to work out that area. Okay, negative. So my answer, just by looking at that component, that is going to be minus 65, tells me I'm going to be at the negative side. So I'm going to have a value of probability that's bigger than 0.5. So not that one, not that one, but still don't have the faintest idea which one of those two. Then we need to say divide by standard deviation divided by n, which is 10 at the square root of that. Okay, so if I do that, and let me quickly do that, 67 divided by square root of 10, I get that is about 24.03, nearly continuous. And then if I say minus 65 divided by that, I get minus 2,7046. I will round that off to a minus 2,70. And then I would need to go to, again, the Z table, minus 2, so we can do it again two ways. Let's just minus 2.7. So minus 2.7 can get that value, but remember it's when referencing that small area. So that is what, 0,0035, which was that, 0,0035. But we want the other part, so that is 0,9965. What we also could have done, because it's symmetrical, we could have gone to a positive table, and then because I'm looking at that bigger area that will be colored in, 2.7 would have given me 0.9965. Okay, I'm just checking where the 0.8051 was. 8051. So it's 0.86. So how would we have gotten to 0.86? Yeah, so I know how we would have gotten to 0.86 out of this. Yeah, not 100% sure how we would. And remember, I now talked about T. So what do we, when we look at degrees of freedom, we need to have a alpha divided by 2, and we need to have n. So the only place where we do get the alpha is when we do work with confidence intervals. So then they would tell us that the alpha is 5% or your confidence interval is 95% or whatever, so that we can go to look at the degrees of freedom. So yes, I wanted just to show this to confuse you a bit, but also to nearly say the only time that you ever need to worry about the T is when we do confidence interval. And when, like Paula said, when very easy so when you're sitting with a confidence interval question, when you look at if it's unknown standard deviation, it's a T. If it's a known standard deviation, it is a Z. So please, the only place where you need to worry about a T is when we work with confidence intervals. No place else. Okay. And again, this one was still, there was a lot of none of the above, but you're not really going to get none of the above in your exam. So there will not be an option of none of the above unless there is information missing. But then they will say one of the options will be there is not enough information. So I think that again is, and I don't know if there was something like that in your assignments, but it might be sometimes that you feel, so they can ask you, so in this instance, standard error of proportion. So you only need to work out the standard error, but in here you maybe could have read, okay, but I now need to work out the Z, but they don't give me enough information. So then the option will be not enough information. Because again, very easy, one can look at this and say, okay, I need to work out, there's my random sample of 60, there's my proportion. Okay, to get to Z, I need to, what was that formula? I think it's the other way around. B minus that. So one could very easily be in that thing of, okay, the previous question, we worked out the Z for the mean. Now we need to work out the Z for the proportion, but wait, I don't have enough. I don't have enough information. But actually what they're asking is just that component. So they want you to work out the standard error. So again, there will be a standard error question in your paper. If it is to do with a standard error where the mean is involved, so then it is that component, or if it is a standard error when you work with a proportion, but there will be a standard error in one of your questions. Okay, so in this instance, standard error of proportion, so they tell us that is 0.6. So there's your pi, or whatever we call it. Then it will be 1 minus 0.6, which is 0.4. And that total answer divided by 60, because that is n. And the square root of that. Okay, so then we will get something like 0.6 times 0.4, which is 0.24 divided by 60. So it gives me 0.004, but we still need to square root. So now look at how sneaky they are. So for that 0.6, there was an option. The 0.004, there's an option. We still need to square root it to get to 0.063. Okay, so nearly they made sure that if you only looked at sigma or pi or whatever one calls that sign, that you might think it's that. If you start with a standard error and you have completed just that part, there's an answer. So again, one can easily make the mistake to have selected here option 2, because your brain says, well, on my calculator I see 0.004. So your brain nearly, oh, but there it is. And forgetting, okay, we need to do one more step. So the final answer is 0.063. So just be again very careful when you're doing it, that you look at what you need to get. So standard error, with standard error, I only need to focus on that component. But okay, that component I did not add now the square root. But then remember that even if you see a nice answer that is already there, just make sure that that was the last step. Okay, so let's then, so for chapter 7, we basically have covered work out Z, work out something with a proportion. Now we go into confidence intervals. Okay, so now they tell us what is the critical value for estimating 99% confidence interval of the mean when the standard deviation is unknown and the sample size is 10. Okay, so we working confidence interval. Interval is basically, we can do Z for the mean, can do a T for the mean, we can do a Z for proportion. Okay, so we definitely know, we're looking at the mean, so it's not Z for proportion. So mean and standard deviation is unknown. So actually we need to get the T. If we got it wrong and said Z, there is your, and let's go quickly to that table. I should have nearly marked that table as well, because that again is a nice table of so I'm hoping I'm gonna get it. Yeah, it was, I think it was study unit 8. I just don't want to go past it and then other. Okay, so again, look at this. There's the 99. So if we just looked at the Z, forgot that it's a T, there would have been your answer. Okay, so we know it's not that one. If we thought about maybe the one that we traditionally use for 95, flip, it's also there. Again, not that one, definitely not unknown, but there was nearly 2 things that we so used to see, very easy to make that mistake. So again, it's not those 2, because that is when the Z is the one that we're using and the standard deviation is known. So we now know it's unknown, the degrees of freedom of alpha divided by 2. And what is it? N minus 1. So we're sitting with n minus 1 is 9. We will go now to the table. Remember 0.01 divided by 2. 0.01 divided by 2 is 0.005. So 0.005 and 9. Okay, so let's go to where was it? T was 9 and 0,005, 3,25. 3,25. So that's the correct one. If we did not say 10 minus 1, but we just used 10, look at what there is. 3,169. 3,169. Okay, so very easy. By getting everything correct, you could have still made just a very simple mistake by saying there's 9 and maybe not even connect it 100% correct, and there are 2 options. So again, if you have printed this, please even have a ruler with you, that you nearly just make sure with that line that you, again, don't make a mistake, because very easy, one can just read that just a bit skew and get the wrong answer. So be just very careful with things like this. Again, this should be actually more easier, the marks. And in here they really tell you standard deviation is unknown, so we know working with a T. That is just automatically we're working with a T. Even, yes, the sample size is also small, but already with unknown, we go straight to a T. Okay. So, yes, question.
Could you calculate this if the standard deviation is known, given?
So,
Will still be a T statistic.
so when the standard deviation is known, we would have said, okay, when it's a Z, then because standard deviation is known, it's a Z, we still work with 99%. I would have used that table. So remember 99%. Let's get to that table. And that is the scary thing, is 99% two-tail 2,58. And there was your answer, option 2, 2,58. Okay, so if standard deviation was known, we would have gone Z, and then option 3 would have been your option. So again, it's like they've, and I don't want to say catered, because they nearly have all the options also that are possible things that you could have gotten wrong. So if you used the Z, here was the answer for you. If you just, as we, if you read that as 95% with the Z, there's a 1,65 or 96 that we nearly every time have seen that's far. If we read the T table just slightly wrong, we get a different answer. If we said, well, the degrees of freedom is just n and not n minus 1, we also get it an answer. So very careful with this one. So it seems very simple, but nearly you could have nearly convinced yourself on all these options nearly that it could have been correct. And that for me nearly is more the risk, because it's not where it's just total other random numbers. It's nearly numbers that you will see on tables or in the graphs and things like that. Okay, so confidence interval, here was the unknown, the T, so they will not ask again. that you need to work out a confidence interval with T. So when we've done it in the previous one, now you can nearly have the thing that the next one will be or confidence interval proportion or confidence interval where the standard deviation is known. So let's see what they ask. And now suddenly 95% confidence interval, population proportion. Okay, so now we know that's going to be 1,96. But let's look at first, in a sample of 60 Durban flooding victims, 36 of them needed shelter. Okay, so first that we're going to work out what the P is. So 36 divided by 60 gives me 0.6. So I know that when I'm now looking at a confidence interval, going to be my lower one, 0.6 is going to be in the middle, and then there's going to be my upper confidence interval. So let's just check. Okay, 0.6 can be here in the middle, can be an option. 0.6 can be in the middle here, can be an option. 0.6 again. Ugh. Okay, so by just looking at that, unfortunately, could not cancel out any of the options yet. So unfortunately, we need to work out the whole thing. So it's the proportion plus minus, remember Z times, and now remember this proportion, which is actually also, if you look at it, it's nearly the standard error that you multiply. So 0.6 plus minus 1,96 times 0.6, 0.4 divided by 60, and that square root. Okay, so then when I multiply that out, I get plus minus 0.124. So already here you could have said, well, I'm only working all of them to 2 decimals. So round it off to 2 decimals, also fine. And then 0.6 minus 0.12 will be 0.48. And then the top one, 0.6 plus that will be equal to 0.72. Which does then give us option 2. Yeah, sure. Unfortunately, so I tried to see if I can cancel out anything. Nothing looked like it could not be an answer. Sorry, and so again, it might be that, yeah, if you needed to guess, unfortunately, there's no ways that you can eliminate anything. It would have been interesting how these are going to be different. So maybe if you use different Z values, you might get to the others. Or if you, yeah, so most likely if you use different Z values, you might get to the other options. Okay, so then in this paper, 2 questions on confidence intervals. Very seldom that you will get free. So not very likely that you will get confidence interval for when we use for Z with a mean, T with a mean, and Z with a proportion. Very seldom that you will get all three. More likely that you will get a T with a mean and a Z with a proportion. So again, if you nearly think of your assignment, there was a T in there was a Z with a proportion in there. Would have been interesting to to know what was in your mock exam, but probably again a T and a Z with proportion. So that is nearly how it will pan out, but again, don't now automatically go for T with a mean, just make sure that standard deviation is unknown. Okay, so then after confidence intervals, we go into hypothesis testing. And now we're looking at, this is more a definition kind of question. So when I saw this in the previous exam, I was like, shoo, this is quite a long one to work out. You need to know a few things. So let's look at what they ask us and which one is correct. Oh, so 0.48 to the lower end and 0.72 to the upper end. So it would have been 0.6 to the lower end minus 0.12, and to the upper end it would have been 0.6 plus the 0.12. That would have given you 0.48 on the lower end and 0.72 at the top end. I am also going to share this afterwards again on the WhatsApp group. So if anybody on here is not on the WhatsApp group, please send. You can still join 0837908387. I'm also going to post both sessions of last night and tonight with this on my Unisa as well, so that you have that. Okay, so hypothesis testing, which one is correct? Okay, so now again, correct. This is my hypothesis. Is it one tail or not? No. Okay, so no, because unknown or not equal to, so not equal to means two tail. So incorrect the first one, we're looking for the correct one. Okay, so now they ask us a few questions on how to work out the T statistic. So if the standard deviation is known, then the applicable test statistic is T is equal to the mean, or your mean minus what was given, true or not? Okay, so no, it's not true. Standard deviation known. Standard deviation known is a Z, not a T. Yeah, cool. So if a standard deviation is unknown, we work with a T. So here I just swapped it around. So again, what I can do with a different questionnaires is have one of these as correct and the other one as incorrect. So again, just be very careful with these, and then especially with the wording. Okay, so let's look at this one. Assuming a Z test is applicable, we reject the null hypothesis when Z is smaller or equal to minus Z, the critical one, or Z is bigger or equal to the critical one, i.e. two-tail rejection rule. Okay, so let's just draw that one. Okay, so here's the the z's that we have calculated with the did they tell us here with the population mean? So let's assume we used the the z because they tell us we need to look at the z. So that was minus z. This was positive z. So we reject the null hypothesis when that z is smaller than. So if I now work out my critical, remember if my z that I have worked out is smaller, that is in the rejection zone. And if it was on the negative side, so they should have actually had, okay, so sorry, there they said the negative. And let me quickly redo that because I've now mixed it up. So they said, and let's just get another color. So that should be also negative z. So I would have nearly already said that is incorrect, but so negative z is smaller or equal to, so here's the critical value, is sitting on the inside, and here the critical value sitting on the inside. Okay, so if the critical value is smaller than my t-stat, and I think I've jotted it down somewhere on other slides as well, we will reject the null hypothesis. And if it is the other way around, we will accept the null hypothesis. So let's just look at this one, assuming we reject the null hypothesis, i.e. the one tail. So you could already have said, but hang on, I'm not working with a one tail. So I'm working with a two tail. So this one is actually automatically yeah, 4 is the correct one. I would just wanted that it should have been minus z, and not just z. So I think there was a typing error. But perfect. So yes. See, and that is because my brain is nearly, I'm looking at if that is the minus z, I'm nearly also wanting the other one to be minus, because you're working on with a two tail on this side, and I know the summary also doesn't have a minus z. So again, I would just have wanted it to be nearly consistent, because we know if we're looking at two tail, on the one side you've got the negative, on the other side you've got the positive. But that's a minor thing nearly, where this one is totally wrong because we're not working with one tail. This one totally wrong because we're not working with one tail. And these ones were also totally wrong because it was misclassified. Okay. So for hypothesis, you could see here they've used this is very I don't want to say technical, but definition. This is definition out and out, because it's asking you at point 2 a formula, at 0.3 a formula, at 0.4 and 5 nearly, well, if this plays out, what it is gonna happen. So this question was very, very definition driven kind of question. So the next one nearly will not be. So now they would give you lots of information, and now suddenly this is actually, I actually only had one on. Okay, so sorry, this is also hypothesis testing. I now wanted to go skip right to the chi-square, but I see it's not. So let's look at this one, and if you see degrees of freedom, that nearly, are we working here with a T? So here we don't know the rest, but so nearly, if I throw in degrees of freedom, aren't we working with a T? So researchers from a university in Durban want to investigate claims that the mean rainfall during the flooding was more than 140 millimeters. Okay, so there's your alternative. More than, if it's more than, is it one tail or two tail? Okay, so more than, perfect. Looking at one tail. Nowhere did they ask us one tail, so it's fine. Then they tell us, consider the following information. N is 30, mean is that, sample standard deviation 76. Okay, so sample standard deviation, that tells me I don't know what the population standard deviation is. So we're working with T. Degrees of freedom for T, N minus 1. N minus 1 is 50 minus 1. 29 is correct. We're looking for the incorrect one. Okay, so now we need to go through all of them. The test statistic, so T-stat, let's rather first go to the critical value one. So critical value that we need to work out is, if you look at the T-table, alpha, and let's just, so alpha divided by 2, 0,005, degrees of freedom 29. Okay, so let's go back. And that's why, again, nearly easier if you can have printed tables, just because you don't really want to use your study guide and scroll the whole time unless you have flagged it or something and you can just skip to it. So degrees of freedom, we set 29. Okay. So you can see I've used this previously. 0,005, 2,756. Okay, why did I divide by 2? Okay, so, and again now, so we originally divided by 2, or I divided by 2, one tail. So I should not be dividing by 2. So again, the simple, easy things to make a mistake with. So there's a reason why they give you that hypothesis with bigger than. So we actually don't divide by 2 because we're working with a one tail. So we take alpha as 0.1. 0.1 with 29, 2,462. Okay, so which is correct. So very easily, I could have made, and I was going to it to say the critical value is 2,756, and then I would have been wrong, because I would have said that one is incorrect, but I would have been caught out because we're working with a one tail and not a two tail. So at the beginning, I was like, okay, we identified one tail. There wasn't anything in here that asked about one tail, but when we looked at the critical value, we only wanted it for that one tail and not two tail. So there's nearly reason in the madness why we wanted to identify the one tail. So then we need to remember one tail, we keep the alpha as is. Okay, so then it's only the one side. Okay, so how would we have worked out the t-stat? So is there somewhere in your formula pages something like that? I'm now can't even remember. Sure, brain is totally a blank. Is there in that, I think, Ian, that tables that you guys shared today on the group, was there a formula for the T? So we must just make sure that it is there. Okay, so we are at hypothesis testing. Let's just quickly, and if it is here, I will gonna, so that was Z. I will make even a quick print screen and just paste it in. Okay. Let's do that. Done a print screen, paste it in here. It's this again is, I don't even think we have, now that I think about it, in any of the previous stuff that we've worked out this year. I don't know even if we've done something like this. I don't know if you guys have seen something like this in the mock exam or in the assignment, but it feels like it's the first time we're actually using a T in hypothesis testing, unless we've done so many that I can't even remember. So, okay, so the formula very similar to that of a Z. So we would still use nearly, and that's maybe why it doesn't seem so weird. We would still have used the X, which is 165, minus the mean of 140, divided by, they've given us a sample standard deviation of 69 divided by n. So this is very similar to the Z. So that's probably why we haven't really worried about it at all. So you would have, with the Z, would have done exactly the same. Only thing that would have been different is that would have been your population standard deviation. So at the top, we will have plus 15. And at the bottom, we will have 76 divided by the square root of 30, which I get as 13,87. So I will just check it again, but if I then multiply that or say 15 divided by that, I get 1,08. Just check. Oof. Let me check again. Ah, that's 25. Oh, silly mistakes. So 25 divided by 13.87 is 1,80. Oh, please don't do the silly mistakes I now made in the exam, because I would have, again, so that one I would have gone wrong by thinking I know what those two was. I would have said, oh, 1,08, 1,80. Freaky that it is the same numbers just swapped around. I would have made two mistakes already in this question, by just assuming things. So that was also correct. So please don't take your time. Don't do what I did. Try to calculate in your head, because then I would have gotten it wrong. Okay, so now we sit with two left. So the one, we do not reject the null hypothesis at 1% level. And the other one is there is enough statistical evidence to conclude that the mean annual rainfall in Durban. Okay, so basically what we need to do here is to say, let's draw that again. The T-stat is 1.8. The critical value is 2,46. So if a T-stat is smaller than the critical value, it was just for opposite, I think, from the T-stat smaller than the critical value, we do not reject null hypothesis. So it's just for opposite from a previous one. T-stat smaller, we do not reject the null hypothesis. Okay, which is correct. So there the T-stat was bigger than the critical value. Here the T-stat is smaller than the critical value. So we do not reject the null hypothesis. And then obviously this one is for opposite, because there is not enough statistical evidence to conclude that the mean annual rainfall during the flooding period was more than. So that one is the incorrect one. Okay. So again, sure. Any shortcuts here? Probably not. I was hoping that degrees of freedom might be wrong. I was hoping that one of the others quickly nearly is wrong, so that, because again, this is, so how I would do it in the exam is look at the degrees of freedom, then look at your table nearly to look for a critical value, and then only work out the T-stat. So hopefully with one of those two already, you got something wrong that you could have eliminated. Yeah, so that would have been one of the things that I would have probably preferred, and not need to work out all of the things. But unfortunately, so this in the exam will take you really a few minutes, and not just as simple, unless obviously there's degrees of freedom is wrong or your critical value is wrong. Okay, so now we go to a question that I have shown you now a few times. We used this table way up front when we looked at probabilities. And now we're using it in the chi-square, because it is looking at two variables and what what the relationship is between the two variables. This is again something that I think is much more possible to be included in your exam than needing to work out the critical value for the chi-square. So again, that takes a lot of time. This one asks you about expected values that you need to work out. It asks you to look at the degrees of freedom. It asks you about the null hypothesis and the alternative hypothesis. So it's nearly a nice one that nearly does everything that you need to know nearly about chi-square testing. So what I would do first is degrees of freedom. So row -1, columns -1. So again, do not include total. So columns -1 is 2 minus 1. Rows -1 is 3 minus 1. So those two multiplied, so it's actually 2 times 1, which is 2. Okay, so the degrees of freedom was the incorrect one. So again, you could have started at the top, then a lot of work in here, a lot of work in here. This was actually now an easy one. So again, it nearly balances out the time. So this one was difficult in lots of things to do. This one is actually easy. But the problem with this one again is if you start at the top, it's going to take you some time. Okay, so and you don't want nearly to spend too much on those calculations if not needed. So this one actually very easy. Degrees of freedom should be 2 and not 4, so that's the incorrect one. But let's just look at the other options. Null hypothesis is that the country of residence and genders are independent. Chi-square, null hypothesis always is looking at the independence, so that's correct. So if null hypothesis is looking at the independence, your alternative is looking at not independent or dependent. So if it's not independent, it is dependent. So look out for that they can use the word dependent or not independent. So what one don't again get caught in use of the English words. So that again is correct. Expected frequency of females in Australia females. So to work out that expected, it would have been total of females times total of Australia divided by the total. Okay, so that hopefully gives us the 45, else we've got a bigger problem. So 260 times 102 divided by 580 gives us 45.72. So that is also correct. So yes, if you didn't start at the degrees of freedom, but started at the top, it's not that long question, but it does take time. Frequency of females again, so 260, and in New Zealand 159, and divided by 580. The 260 times 159 divided by 580 will give us 71.28. Okay, so again, was able to calculate it. It is correct. It's not that long, but it is a minute or two that you could have spent elsewhere by going to the degrees of freedom first. So again, just when you're in that exam, looking at the question, try to see if there's not always an easier option first to pick before you start just looking at. Again, if I look at the previous one, yeah, I would have looked at degrees of freedom as well first. Then I would have put the critical value. But then, unfortunately, if both of them are correct, then I normally just look at the next one and the next one and the next one. So here, if degrees of freedom was correct, I would have gone to my next options is for hypothesis testing. If those two are correct, then I will only go to the ones that I need to actually do calculations. Okay, so last two questions. So, and again, if you guys look at nearly the last few that, or the ones that we did today, 14, I wouldn't have used Excel. 15, I wouldn't have used Excel. 16, also not have used Excel. 17, I might have used Excel, but again, not needed nearly. 18, I only needed to work out the standard errors. So again, probably would not have used Excel. Here, you need to go straight to the tables and things. So again, probably would not used Excel. Yeah, I might have used Excel with confidence interval that was pre-set up. But again, it's not that it's not impossible to do without Excel. This one, I couldn't have used Excel. So again, no use for Excel here. This one, again, only at the T-stat, I could have pre-programmed this, but probably also not a big train smash. Yeah, again, not a big train smash to not be able to use Excel. And when you look at the last two with regression, we also don't get data. So without data, I can also not do anything. So in this exam, I would probably not have used Excel a lot. So again, to the 1510 guys, it might be that all of your questions is also set up that you actually don't need Excel. So so it might be there's a reason why the lecturer said for you guys that we're not even going to Excel, because it might even be that you don't need it. So, or to that extreme case as how we have done some of the others. So again, I think we, especially with these last two questions, it's nearly programmed regression. We get data, we can get the answers, but we now need to get answers without any data. So let's look at question 24, because this for me, again, very much like the one we did, was it, I think, on Sunday, where we need to know what is confidence or coefficient of correlation. We need to know what is coefficient of determination. So they give us a lot of information here. They want us to look at certain things, but let's look at this one. Let's look first at the definitions. Coefficient of correlation is always positive. Correct or not? And your coefficient of correlation is R. So is it always positive? No. So you can have a positive coefficient of correlation and you can have a negative one. So that's incorrect. We're looking for the correct one. Okay. Unfortunately, not great that the coefficient of determination is always negative. Hey, no. Incorrect. Coefficient of correlation, because it's R squared, is always positive. Always, always, always. Because even if your R is negative, negative times a negative gives you a positive. Positive times positive gives you a positive. So your coefficient of determination is always, always positive. Okay, so unfortunately, both of them is incorrect. We're looking for the correct answer. Okay, so let's look at, so they tell us R square is 0.25 or 27. So if R square is 0.27, then coefficient of correlation, which is R, is basically 2, or 0.27 square root. Okay, so hopefully that gives me the answer. So square root of 0.27, 0.5196. Did I work that out correctly? Let me just quickly check. 0.27, 0.5196. Okay, positive or negative. Okay, so let's just look at, so remember it can be positive or negative. So if I round that off, plus minus 0.52. In Sunday session, remember I said, look at R and look at your slope. So if your slope is positive, R is positive. If your slope is negative, like it is, your R must be negative. Okay, so your R always are exactly the same as the sign as your slope. So negative slope, negative R, so the coefficient of correlation is actually minus 0.52. Okay, very technical this one, because one wants to say, well, yes, the square root of that gives me 0.52, but remember the correlation can be positive or negative. So if that was plus, then that would have been positive. It's negative, so your coefficient of correlation will always then also be negative. Okay, so unfortunately, that is also the incorrect one. The value of y when x is 0. So when x is 0, value is, yeah, okay, so value is 47. Okay, not 46.75. So incorrect. I think if you made that equal to 1, you would have then had 46.75. So it's probably what they want to see, that you actually make that x 0, then that would have fallen away. So your y would be 47 and not 46.75. So the last one is correct, but let's just then look at it. So 27% your R square of a variation in y is explained by x. which is correct. So 27%. So if we translate that into percentage, that is 27%. So 27% of your variation in Y is explained by X. Okay, so, and again, you can look at the definition of the R square. That is what it does say, is that your R square is showing you what the variation in Y is explained by X. So, so in this one, a lot of definition again, because it asks you about the coefficient of correlation and more definition than anything else. It asks you about the coefficient of determination. It asks you to explain the variation in Y. Then more technical, but again, linked to nearly understanding that the sign of your slope and the sign of your correlation needs to be the same. So that one was the incorrect one. And then so what they could do again with the different exam papers, they could have asked the value of Y when X is 7. So that you put 7 in there, 7 times 0.25 gives you a value, and you subtract that from 47. So again, it does not always need to be 0. They can use anything to put in Z, or sorry, in X, and you can work out something. Okay, so question 24 on regression. A lot of the things nearly in here was more definition based. And then question 25, again, very definition based. So nearly everything that you needed in 24, you need to know in 25 as well. So here they tell us if a coefficient of correlation is 0. So what, again, coefficient of correlation is R. So if R is equal to 0, the slope of a regression line is 0. Yes or no? Okay, perfect. Slope of regression line is 0. Only A, okay, so it could be that one, not that one, could be that one, could be that one, could be that one. Okay, at least we eliminated one of them. The coefficient of determination is 0. So if R is 0, what is R square? Okay, also 0. So B is correct. Okay, so only A, no, it can be A, B, and maybe C, A and B only, and C only. So at least another one. So now we're sitting with two options that we can go through. If coefficient of correlation is 0, there is no relationship between X and Y. Correct or not?
I would say correct.
Perfect. Correct. So there is no relationship. So if it was 0.1, then there is a relationship. It's a weak positive, but when it's 0, absolutely no relationship. So A, B, and C was the correct ones. Okay, so this was an interesting paper because a lot of theory in it. There was places where you need to do calculations as well. So you can see there was definitely, but this one also long, so, but a lot of theory. So just be really careful that we don't go too much on on theory on the one side, but also too much practical. So again, probably your exam is going to be a bit more of a mix of the two, but it will also be structured that yes, you can use Excel 1610 guys, you're allowed to use it, but it might even be that you're not going to need it for everything. So my recommendation, and why we have a few minutes nearly left, is focus more nearly for your exam to get the question nearly correct in identifying what they ask. Specifically, the standard deviation, if it's unknown or known, for confidence intervals and hypothesis. Then nearly with your discrete binomial Poisson, check there, because normally in those ones, they're going to ask you to work out the expected value. So only discrete do we nearly need Excel, but also it's not critical. And then I think the important other one that we need to focus on nearly is with the probabilities. So again, if we look at probability, they will ask you something about independence and mutually exclusive. So know how to nearly calculate those two. And then they will ask you nearly the ones about something given something else. The other one that in this one was missing was for OR. So they could ask you to work out for OR as well, but it's nearly on the probabilities, nearly getting a view of both. Okay, so let's stop, and let's use the last few minutes. Any other questions from your side? I'm hoping that you guys are well prepared. You still have tomorrow, so when on the WhatsApp we can chat until early morning of Thursday. Then I will probably mute the WhatsApp group. Also, we don't really want with Iris, again, don't want to nearly tempt that you're using other devices, especially a cell phone, because I'm always worried that might be very easily picked up when you suddenly have that in a camera frame, and automatically that will be flagged nearly. So and it's not for you to now get easy ways to cheat, but if you using your cell phone because your PDFs are on there, have it at the back of the camera that the camera can't see it. So if you then have your cell phone against the wall with your screen that's a bit in front of that, because again, let's be honest, I have all my PDFs nearly on my phone. So again, now to get my PDFs onto my laptop, again, is a struggle. So again, if you use your phone, don't put it down on the table, say next to your calculator, because again, I'm worried that they Iris picks that up. But if it is behind the screen and you look at it again, it will probably not be picked up. But again, don't try to use it for messaging. It's one doesn't know what the settings of all this stuff is to to pick up certain things. If you got an issue at the beginning of a paper with logging in and things like that, then please WhatsApp me. I know, yes, I said no, don't, but specifically with logging in and those kind of things. If there is a problem with the website, I will send out a broadcast nearly, because then everybody will be struggling. With Iris, sort it out that you know that it's working before the exam, please. Don't that morning. That I like, Patrick. I like that. That nearly put it onto airplane mode, because then they can't suddenly ping something or alarm bells goes off or your phone is ringing and those things. That agree. Nearly put it on airplane mode so that those things don't alerts and those things don't come through. On either side, sort it out before you write. Don't, if you are now having problems with it, try to, I know again, it's not easy getting to one of the UNISA areas, but nearly see, put it on our chat, put it on UNISA moral support group that I also have. I'll share that for you guys as well, because again, but please, Iris must be sorted out before you write exam. We don't want to sort that out on the Thursday morning, because then it's going to be chaos. Then everybody is stressed. So please just make sure that you've downloaded it, you followed the process, and the things that need to pop up have popped up and things like that. What I've now realized, and I can't access Iris because don't have a student number or anything, and lots of other things that I can't download on my work PC. So again, there's things that you need to do. So with Iris, you need an form of identification. So then it knows it's you, so that you don't need extra passwords, because if you need to add a password, it has loaded incorrectly. Okay, so those kind of things that just be sorted out. Okay, the floor is open. Other questions for you guys? The 1510 guys, we'll watch how it goes with 1610, but we basically going to copy and repeat. So no class on Thursday, but we will have class on Sunday, class on Monday, class on Tuesday, so that you guys are also prepared for when you write next Thursday. So we basically nearly copy and paste what we've done in the last 3 days with 1610. We're going to do with you guys as well. Okay. Now, anybody else have any other questions? Else it is a good night to everybody. But please, is there anybody else that have any question that they want to ask? Anything like that? Okay. Then let's call it the evening. Absolute good luck to you
Sergi,
guys. I hope it. Okay, are we allowed? You must ask what are allowed. Yes. 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 So you are allowed to use notes. The big thing that, again, for the 1610 guys, that you're not allowed to do is communicate with your fellow students. So any messaging chat functions on your PC will give you away instantaneously. So don't even have Gmail open. So nearly have all of that closed. So no, the big thing is messaging. The second big thing is that the camera only picks up you. So don't even let somebody bring you coffee while you're writing or something like that, because just again, that might flag that somebody else's arm was in a picture, and it can be flagged as somebody's assisting you. And yes, we know it's not assisting you, but just avoid those things. Yeah, so the things that, so again, PDF is not in your browser. So yes, please don't. And let's be honest, if you going to try to Google something, it's probably going to take you so long to get to an answer in any case. But if you want to use Excel, use Excel, use the calculations that I sent you over Excel. You can do your own setup of the calculations. So by all means, you can do that. You can use Excel's internal formulas as well, but then just make sure that, again, you know it beforehand, and don't now in the exam try to work it out. Yes, and again, Patrick, that's fine. And remember, Excel, and that's why it's unfortunate for the 1510, but Excel is, it's not a communication tool, it's a Microsoft approved. So again, if you've got PDF open, you've got Excel open, you've got Word open, those things are standard things that are there for you to use. So your notes are in PDF. It might be that some of you have notes on a Word document. Again, if you look at the tables, not all of us are privileged in that sense that you have a place where you can print the notes. So again, that's why I nearly want the 1510 guys to have complained after the exam at the Ombudsman or somewhere else, because certain things is just unfair. So if UNISA hasn't printed copies and you need you're writing an open exam book, then it should not be an issue to use a PDF. So I nearly want the 1510 guys to later nearly complain about the whole process, because I think there's certain things that is just totally unfair. I can understand Excel being not included because they want you to work out, but let's be honest, if they've provided all your study material as PDFs, and now for 1510, I think you guys said you're not allowed to open that. That for me is ridiculous. So I'm now going off here on my day, but and I think you guys feel the same. So there's certain things that are just stupid. So in that instance, but the 1510 guys, we'll chat on that on Sunday, Monday, and Tuesday. And even if you need my help in assistance to to complain about it, I'll gladly assist you to complain afterwards about the whole process. So for the 1510, 1610, use all legal things that you are allowed to use. So, but please, that camera it does pick up. It's very sensitive. So please don't even if you're writing your exam from work, nearly see if you can get the office that you're writing in. See that you, because the iris does pick up noise very, very good. So if you're sitting in an office environment and there's chatter around, it will pick it up. You guys are not allowed to use headphones. So again, please don't use headphones when you write, because it will pick that up. It does not know if you are using headphones to listen to somebody giving you instructions. So that's why they don't want you to use headphones, because again, you could have your cell phone can be in the room next to you on Bluetooth, and you can be speaking to somebody on Bluetooth speak or headphones. So don't put in headphones because it will be flat. So those kind of things, again, one can understand, because that is easy ways of cheating. Again, it is also, I can't nearly work without headphones again, but again, one more understands that than something else. So again, I know it's, if you, and it's a weird example nearly, but if you in the process needs to go to the loo or something, and you're on a laptop, I know it's completely insane, but nearly take with your laptop with you in the worst case scenario, because again, you don't want to show Iris that you're leaving and it doesn't pick you up, rather that it picks you up with weird noises in the background than actually flagging you that you may be going elsewhere. Because what they will go through, if there's flags, they will nearly look at what the flags is, so that it's not automatically a fail because you flagged. And that's why also with your exam marks, yes, it's multiple choice. The computer actually, after you've written, could have given your marks, but they need to go through that process of checking. So individually, all of your IRIS's profiles will be checked. So that's nearly why it takes so long to nearly give you the results. It's not because they couldn't automatically give it to you. They nearly need to verify each one in the process. So again, just nearly try to things that you can exclude from a process, don't do it. So if you're not planning to use Excel, don't even have it open. So nearly that process. If you have printed copies and you don't want to use the PDF, don't even have it open. Because what it will probably do in the process says you've got PDF open, but then again, it's open book. They can, at least we've got a reason why it's open. So those kind of flags will probably also come in, but there's explanation for it. There's not explanation for you leaving a screen for 4 or 5 minutes. So those things are more, so rather take your PC with you, rather not, if you want to get coffee, all those things, rather have it with you when you start, that nobody needs to bring you anything in that instance. Just that, again, things don't need to be complicated when you guys write. Okay, so that is it. Yeah, again, the chat will stay open. I'm gonna post now the video and the rest of the presentation for you guys as well on the WhatsApp chat. And still, if there's questions from now till tomorrow evening, please post it. I think the mock exam is open until 8 o'clock. And the reason why second screen is not allowed, apparently. So, so I don't know, and this is, I don't know if when you attach a second screen, but you have it mirror your, instead of having it as a second device, I don't know if that is allowed. So what, and the other guys can come
Yes,
in
yes,
here,
it is.
but okay, so you can mirror it, but not have it as two devices nearly.
Yeah, so Iris won't even let you, well, it depends. Iris can be configured to allow multiple screens, and then you can
Okay.
have two separate screens. But if you have it mirrored, whether you have two and you mirror it, and Iris
Yes.
doesn't allow you to have more than one, it will actually start. If you have them non-mirrored, it won't even start until you've disabled your other screen.
Okay. Okay, and so that can also be certain reasons why Iris might, so it might not be anything to do with the Iris setup, kind of. It might be that something is a second screen and things like that. Yeah, so again, I would have hated it because my laptop is so small. I would have struggled to nearly work out anything. So I would not be able to use tables on my screen because I would probably get confused with the numbers. So yeah, so there's certain things with Iris that it's just, it won't even, like Patrick now said, it won't even allow you to do startups and things like that. So okay, see, so that's good to note. So if, like now where I said second screen is not even allowed, so don't even try it because it's nearly, there will be then issues. So don't even try to sneak that one into and say, but maybe it's wireless, or maybe it, apparently then it will not even. So yeah, so nearly so, and I think that could also then explain some of the problems some of the students are having, is because that when you start up then Iris, because when it's starting up already not correctly, and you think it's something with your profile nearly, but when it's actually because of the settings of your PC and with second screens and those kind of things. So just again, be careful. I don't know if I say it strictly when you upload Iris and when it starts, those kind of things. Okay, so it does warn you. So again, please then follow those kind of warnings, because I know there's never been a warning about you can't use PDF and you can't do that. So there's always warnings about um, certain so other so if it starts in Chrome, that you don't have another Chrome page nearly open and those kind of things. Okay, so, and again, thanks, Patrick. That's also a nice one to share. So, guys listening to this later on, and you might not be able to see the chat. One of the things that Patrick mentioned is the biggest issue most people have is that they don't click on the virtual screen to share your desktop. So I think that again is important. So again, small things that might nearly prohibit you from writing is these small things. So, and that is nearly most things. Again, please sort that out tomorrow as early as possible, that we can nearly, yeah. So that's important one of don't complete. So in the, as you're writing, so that might not be to do with Iris, but as you're writing, and you guys now would have done the mock exam. So if you answer question 1 and go to question 2, it would have saved question 1 in the memory. So if you now continue, you get up until question 20, your time is up, it closes down, everything that you have done are automatically saved. Okay, so you don't need to worry that. So again, if you have not completed your 25 questions in the allotted time period, it's okay. Because at each question it is saved to memory, so that when your session ends, it automatically uploads all the questions that you have gone through to the system. So you don't need, with 1 minute left, now click just to get to the last question, kind of. That's not needed. It automatically saves your answers. The one thing that is a problem, so what happens normally if something freezes? I know with the exam, if you go back, log into it, it's supposed to start off where you ended. So this is again the important one. So if something like this happens where you only 2 or 3 questions into your paper, everything freezes up, it doesn't want, it hangs, then also nearly let me know. Because what I will then ask you is, what's your student number? And I will send that directly to the lecturer. Because what we've done in previous times is that he loads a second attempt nearly, so that you can do a second attempt. So that when something like that happens, you can do a second attempt. But that we nearly then handle separately, so that, because again, please don't, after you've done your session and now want to do a second attempt, that will just mess up everything. So don't go into nearly a second attempt unless you were like at question 1 or 2, something crashed. Then we need to nearly just mark it with the lecturer, so that we can just make sure that you can get into the system again and continue. Okay. But let's hope, sure, those things are not happening. Touch wood, that there's no load shedding in any areas. Last year this time we were in stage 6 load shedding for this exam, so it was absolutely chaos. I think we were in load shedding stage 6. There was the floods in KZN. It was absolute chaos. Um, so so touch wood that anything like that doesn't happen at all this time, and that we have a smooth one. I think you guys are, yes, we moaning that you're writing early, but I think with not a lot of students actually have started yet, it might be that the online systems will not be overloaded, so that there's not other subjects like economics or something like that that there's a lot of students writing with you guys. So hopefully that then the system holds and all those kind of things as well. Yeah, but good luck, guys. And we'll chat again still on WhatsApp, and then all the best for Thursday. Cool.
and the acceleration of it.
Social
Yeah,
media
I'm
kind of
with you.
shaped me. Every time I was posting something, when I saw the appreciation of my